Ever look up at the night sky and just, like, feel a little shiver? Like the universe is kind of winking at you saying, hey, you think you know what's out there? Think again. According to our research, it seems like every day brings some wild new discovery that really makes you question, like, what is reality even? Is the universe really expanding like we're told? Or could that be some kind of crazy cosmic illusion? What if stars are, like, conscious? And what if this reality, the one we're experiencing right now, is just one tiny piece of something much, much bigger? Welcome to The Lonely Star, the show where we dive deep into the mysteries that keep us staring up at the sky.
The coolest thing is, this isn't just like, stoner philosophy. These ideas are coming from real science, from observations that are totally shaking up what we thought we knew about the universe. It really makes you realize how much we still don't know.
Totally. So on today's deep dive, we're going to be exploring some seriously wild ideas and scientific findings that are making even the top cosmologists scratch their heads. We're talking about stuff that makes you question the entire universe, from its grand structure down to, like, the smallest paradoxes. And we're not just going to lay it all out there. We're going to unpack it, pull out the most fascinating bits, and hopefully give you, our listener, a whole new perspective on the cosmos.
Well, might be a little mysterious, maybe even a bit scary, but definitely thought-provoking.
Okay, so let's jump right in. First up, we got to talk about the big picture, the universe itself. Our research says the James Webb Space Telescope, that super powerful new telescope you've got up there, has been sending back some pretty mind-blowing images. What's got everyone so excited and maybe a little freaked out.
Well, what's really grabbing everyone's attention are these pictures of early galaxies. We're talking about galaxies that formed like way back in the universe's early days, just a few billion years after the Big Bang. The thing is, Webb is showing us galaxies that are way bigger and more structured than we ever expected to see so early on.
So, like, baby galaxies that look like they've already been hitting the gym for billions of years.
Yeah, exactly. One galaxy they found, nicknamed Big Wheel, it's a spiral galaxy, just like our own Milky Way, and it's almost as big and spinning just as fast. But here's the crazy part. This thing existed when the universe was only about 15% of its current age.
15%. That's like just a cosmic toddler. It's like watching a newborn baby suddenly stand up and start running a marathon. It doesn't fit with what we thought we knew about how galaxies form, does it? I mean, I always thought it took, like, forever for gravity to pull together enough stuff to make these giant structures.
You got it. The standard model of cosmology says gravity needed a ton of time to do its thing, to pull in enough matter and create these complex structures. So in the early universe, galaxies should have been smaller, clumpier, definitely not as well defined as what we're seeing now.
So finding these big, mature galaxies so early in the universe's history, like the Big Wheel, it means we might have to rethink how gravity, dark matter, and maybe even some stuff we don't know about yet all worked together back then.
Exactly. We might be missing some key ingredients in our recipe for the early universe.
Okay, so it's not just these weirdly mature early galaxies that are messing with our understanding of the cosmos, right? There's also something funky going on with dark energy, that mysterious force that's supposedly making the universe expand faster and faster. Remind me, what is dark energy again?
Right. So back in 1998, scientists discovered this crazy thing. The universe isn't just expanding, it's expanding faster and faster. Before that, everyone thought gravity would be like slowing things down. But nope, the universe is actually accelerating. And to explain this, they came up with this idea of dark energy, this invisible force that's pushing everything apart.
So, like, the universe is hitting the gas pedal instead of the brakes.
Yeah, kinda. But here's the really wild part. New findings are suggesting that dark energy might not be constant. Like, it could be changing over time.
Changing. Whoa. How would that change how we see the universe? I always thought Einstein's theories and the lambda CDM model, that big theory of how the universe evolved that talks about dark matter and dark energy, all that stuff. I thought they assumed dark energy was pretty stable.
Right, exactly. If dark energy is changing, it throws a major wrench into Einstein's ideas and the whole standard model. It means the universe might not be expanding at a constant rate.
Yeah.
And that means we'd have to rethink things like how old the universe actually is, what its future holds, all that.
Okay, so we've got these super developed baby galaxies and maybe not so constant dark energy. It feels like the universe is playing a game of cosmic hide and seek with us.
Oh, yeah, for sure. And because of these big mysteries, scientists are starting to look at other ways to explain how the universe works. One idea that's super interesting is called timescape cosmology.
Timescape cosmology. That sounds like something straight out of Star Trek. What's that all about?
So imagine this. What if time doesn't flow at the same speed everywhere in the universe?
Wait, like time travel?
Not exactly. Timescape cosmology says that time moves slower in places where gravity is stronger, like in galaxies, and faster in those vast empty spaces between galaxies called voids.
Okay, so if you had two clocks, one chilling in a galaxy and one hanging out in a void, the void clock would be ticking faster over billions of years.
Exactly. And over like the entire history of the universe, those tiny differences in the flow of time would add up to some pretty big effects. The voids, where time is moving faster, would have had more time to expand.
So are you saying those voids are expanding faster than the galaxies, and that's what makes it look like the whole universe is accelerating? Like, it's an illusion.
You got it. Timescape cosmology basically says that what we think is dark energy pushing everything apart might actually just be the result of time flowing at different speeds in different parts of the universe. And get this, in 2017, there was a study that showed timescape cosmology might actually fit with some of our observations even better than the standard model, that lambda CDM thing we were talking about.
Whoa. So instead of some mysterious force, maybe it's just time itself that's making the universe expand faster. It makes you wonder, what even is time, right? Okay, so we've got early galaxies that are way too big for their britches, dark energy that's maybe not so constant after all, and now time itself is playing tricks on us. And there's more, right? The Webb telescope found something strange about how those early galaxies are rotating.
Yeah, this is another one that really threw everyone for a loop. Scientists looked at a bunch of early galaxies, like around 30,000 of them, and they found that most of them seemed to be spinning in the same direction.
Spinning in the same direction. But how? I thought after the Big Bang, everything should have been super chaotic, with galaxies forming and spinning every which way.
That's what everyone thought. The Big Bang Theory says that all the stuff in the early universe should have been jumbled up, leading to galaxies spinning randomly. This whole spinning in the same direction thing, it just doesn't fit.
So if they're not spinning randomly, what's making them line up like that? Could it be like some kind of initial spin in the fabric of the early universe itself?
That's one possibility scientists are looking into. Maybe the early universe wasn't as smooth and uniform as we thought. Maybe there was some kind of big cosmic spin that influenced the galaxies forming inside it. Another idea, even more out there, is the black hole universe hypothesis.
The black hole universe hypothesis. Now, that sounds like something from a sci-fi movie. Remind me what that's about.
Okay, imagine this. Our entire universe, everything we can see, is actually inside a giant black hole that exists in some higher dimension. In this scenario, the Big Bang would be like the birth of our universe as the inside of this black hole expands. And if that black hole is spinning, it could have given a preferred spin direction to the galaxies forming inside it.
Whoa. So not only are we questioning dark energy in the Big Bang, we might be living inside a giant black hole, mind officially blown. Okay, let's shift gears for a second. We've been talking about stuff that's like mind-bogglingly huge. Now let's zoom in on something that seems pretty simple, like a rolling wheel. But according to our research, even something as everyday as a wheel can hide some pretty deep secrets about, like infinity and stuff. Tell me about this Aristotle's wheel paradox.
This is a classic brain teaser, man. It's been messing with people's heads since like ancient Greece. Picture a regular wheel, right? Now picture a smaller circle inside that wheel sharing the same center. If you roll that whole thing one full rotation, both the outer edge of the big wheel and the smaller circle inside, they both travel the same distance.
Wait, what? The smaller circle has a smaller circumference, so it should travel a shorter distance, right? How does it keep up with the bigger circle? It's like some kind of magic trick.
I know, right? This paradox has stumped a lot of smart people throughout history. There was this 17th century French mathematician, Roberval, who focused on the path a point on the edge of a rolling circle traces called a cycloid curve. He noticed that the path of the inner circle seemed to stretch out compared to its actual size. Then there was Galileo, who imagined the wheel as a polygon with a ton of sides. He figured out that as the outer polygon rolls, the inner polygon kind of skips along, losing contact with the surface for a moment.
So the smaller circle is basically hopping as the wheel rolls.
Kinda. Galileo realized that even though the inner circle is attached to the bigger one, it's not always touching the ground. He figured this was happening on an infinitely small scale, even with smooth circles. So the inner circle is kind of being dragged along by the outer circle covering the same distance, even though it's smaller.
Okay, so the outer circle is rolling smoothly, and the inner circle is doing this weird slipping and skipping thing. But why does it matter?
Because it makes us question what it even means for two things to be equal when they're moving. Like, how can two circles of different sizes create the same number of contact points as they roll? This whole thing takes us straight into the world of infinity, and that's where things get really weird.
Infinity. How does a wheel lead to infinity?
Well, think about it. The outer circle and the inner circle, they both have an infinite number of points, right? And those points are all touching the ground as the wheel rolls. But how can something smaller have the same number of points as something bigger? This is where this guy, Cantor, comes in. He basically revolutionized how we think about infinity.
Yeah, I've heard of Cantor. He's the one who said they're different sizes of infinity, right?
Yeah. Exactly. He showed that the infinity of whole numbers, like 1, 2, 3, going on forever, is actually smaller than the infinity of all real numbers, which includes all the fractions and decimals too. It's mind-blowing. You can list all the whole numbers, even if it takes forever, but you can't even begin to list all the real numbers. There's always going to be more of them.
Okay, so some infinities are bigger than others.
Yeah.
How does that relate to our wheel?
Well, the number of points on the inner circle and the outer circle, they're both what we call uncountably infinite. That means, in terms of how many points they have, they're equal, even though their lengths are different. It just goes to show that when you start messing with infinity, our normal ideas about size and equality kind of go out the window.
So a simple wheel, something we see every day, opens up a whole can of worms about the nature of infinity. Kind of beautiful in a weird way.
Yeah.
Okay, let's move on to something even more mind-bending. We've been talking about paradoxes in math, but our research also points to some pretty wild ideas about the nature of the universe itself. Like, what if the cosmos is more than just a bunch of matter and energy? What if it's like conscious? This is some next level stuff.
Yeah, this is definitely where science meets philosophy, and maybe even a little bit of spirituality. Most scientists see the universe as a giant machine governed by physical laws, but there are some people who believe it's much more than that.
So like the universe is alive.
Some people believe that, yeah. They see all the interconnectedness in the cosmos, how everything seems to work together in this amazing way, and they say it can't be just random chance. They believe there's some kind of underlying consciousness, some intelligence that's guiding everything.
Okay, that's pretty wild. And then there's this idea that keeps popping up about the universe being eternal and cyclical. Like it's not just a one-time Big Bang and then that's it, but more like a cosmic heartbeat, expanding and contracting forever.
Right. This idea shows up in a lot of ancient traditions, like the Hindu idea of Brahma breathing the universe in and out. But there are some modern theories that suggest something similar. There's the Big Bounce model, which says our Big Bang wasn't the beginning, but just a rebound from a previous universe that collapsed. And there are other theories, like plasma cosmology and electric universe theories, that suggest the universe might be eternal and driven by electromagnetic forces.
So instead of a beginning and an end, maybe it's just an endless cycle of creation and destruction. And what about that idea of the cosmic fabric being conscious? Where does that come from?
This idea is rooted in ancient philosophies like Hermeticism and Kabbalah. They see the universe as inherently imbued with consciousness, not just a bunch of dead matter. There's also the concept of the Akashic records, this idea of a cosmic memory bank that stores everything that's ever happened. Some people even point to quantum mechanics, the theory that describes how tiny particles behave. There's this thing called the observer effect, which basically says that the act of observing something can actually change it.
So maybe by observing the universe, we're actually influencing it. That's trippy. And some of our sources even suggest that the whole Big Bang narrative might be like a story we've been told for a reason. Like maybe it was promoted to get rid of the need for a creator god or something. That's a pretty bold statement.
Yeah, it is. Some people argue that the Big Bang Theory was more readily accepted because it fit with the idea of a creation event, like in religious texts. It's definitely something to think about. How do our beliefs and cultural biases shape what we accept as scientific truth?
Okay, and then there's this idea of the universe being like a giant energy field, not just a bunch of separate objects. What would that mean for us if it were true?
Well, if everything is connected by this underlying energy field, it could open up some incredible possibilities. Some people believe it could lead to things like free energy, basically tapping into the universe's energy source directly. It also makes you think about things like interdimensional travel, like what if we could manipulate this energy field to travel between dimensions?
Whoa, now that's some sci-fi stuff. And then there are all those weird experiences people have, like déjà vu, the Mandela Effect, and the whole idea of parallel realities. How do those fit into this bigger picture of a maybe conscious, maybe cyclical universe?
These experiences are like little glitches in the matrix, right? People who believe in a multidimensional reality say things like déjà vu. That feeling of having already lived something could be a glimpse into another timeline. And the Mandela Effect, where lots of people misremember the same thing, could be a sign that our reality is shifting or changing. And then there's the idea of quantum immortality, which basically says that when you die in one reality, your consciousness jumps to another one.
Whoa. So death is just a door to another reality. Mind blown again. And speaking of mind-blowing, what about the holographic universe theory? That's the one where our three-dimensional reality is actually a projection from a two-dimensional surface, right?
Yeah, that one's a real head scratcher. It's a pretty popular theory in physics these days. It basically says that all the information that makes up our world is stored on a two-dimensional surface, like a giant cosmic hard drive, and our three-dimensional reality is just a projection of that information.
It's like the universe is a giant hologram. So what's even real anymore? And then, of course, there's the most radical idea of all, that time is an illusion and that our reality is a simulation. We might even be living in some kind of cosmic cycle managed by, like, super advanced beings or something. That's getting pretty out there, even for this show.
I know, right? It sounds like a sci-fi movie plot, but there are people who take these ideas seriously. They point to ancient myths and texts that talk about a creator god or beings who shaped our reality. Some people even think there might be a reason for these cycles, like maybe it's all a giant experiment or a game.
Wow, so we could be characters in some kind of cosmic video game.
Yeah.
That's both terrifying and exhilarating at the same time.
Exactly. The point is there are so many different ways to look at the universe. The more we learn, the more we realize we don't know.
Yeah, our deep dive today has taken us from the birth of the universe to the nature of time and infinity, and even to the idea that reality itself might be a construct. It's enough to make your head spin.
The big question is, what do all these ideas mean for us? If the universe is more than just a giant machine, if it's conscious, if it's cyclical, what does that say about our place in it all?
Right. Are we just tiny specks in this grand cosmic drama? Or do we play a bigger role than we realize? Maybe, just maybe, by asking these questions, by exploring these wild ideas, we're actually shaping the reality we experience.
That's a great question for you, the listener, to ponder. What if our curiosity, our willingness to question everything, is actually a key part of the universe's evolution?
Well, that's all the time we have for today's deep dive on the Lonely Star. We hope you enjoyed this cosmic roller coaster ride.
Make sure to join us next time for another deep dive into the mysteries of the universe.
Until then, remember, the truth is stranger than fiction. Goodbye.